Welcome to my channel. In this session we are going to discuss about noise theory, which is the basic concept for EC 8491 communication engineering paper under ECE, the fourth semester. So before going to know about what is noise, we need to go for the introduction, why we study this noise particularly. So there are basically two mathematical models available to describe a phenomenon, which can be either deterministic or stochastic. So deterministic in the sense which is determined, so it can be found, whereas stochastic is nothing but which is random in nature, or it is probabilistic. So which can be given or modeled by means of using a mathematical formulation is called deterministic model, whereas which cannot be predicted is called as stochastic model. So what is deterministic model? We will see as per the definition here. A model is said to be deterministic if there is no uncertainty. There is certainly we cannot predict about anything. That is, a model is said to be deterministic if there is no uncertainty about its time dependent behavior at any instant of time. So we cannot predict it at any instant of time. That is, we can certainly tell about this behavior taking at a particular time duration. So example, if I am giving a signal, and this signal, if I want to determine what is here, what is the activity here based, it can be determined based on the time duration parameter, that is at any instant of time. So that is why it is called as deterministic model. So where it is suitable? So it is most suitable physical model in many real world problems because it involves many unknown factors. So it is, first of all, it is suitable for many real world problems where we need to find the unknown factors, and we can simply in a single word or a single definition we can say that deterministic models are able to define or determine it and find its output which is certain in nature. So we can find its certainty, that is called as deterministic model. So what is stochastic model? So stochastic is nothing but where this real world scenario or this physical parameters which are always, that is, we can say it is random in nature, we can't predict it because it is a natural phenomenon. So we can't predict it. Example, or any voice parameter or any temperature, humidity, which is all these parameters which cannot be predicted. So it is always changing time to time. So modeling such parameters lie in availing the probability between any specified limits. So this type of models are basically random in nature. Hence it is called as stochastic models. For example, consider a radio communication systems. So where I am considering a transmitting and a receiver, between this I am considering this as a radio communication establishment between a source and destination, and it is affected, it is inferred through a channel which is again interfered through a noise. As said above, due to this channel parameters, that is the channel parameters which is nothing but an open medium, right, which is easily inferred with noise because noise is unavoidable parameter. The information from the transmitter to the receiver will be affected by this noise in the channel. So if the channel is assumed to be an electromagnetic spectrum, the interference, that is the noise or interference, is represented as a spurious electromagnetic waves which is operating in the vicinity of the radio receivers, that is which can be available in the radio receivers along with the signal which is transmitted. So example, when you switch on an FM radio, immediately if you are unable to find out the band, that is for example any radio band which is like Rainbow FM or Suryan FM, whatever it is, there will be some noise sound, just like any noise will be heard. That noise is nothing but due to the effect in the channel which is carried along through the signal to the receiver end. when the band is finally recovered, that noise will be, it is designed in such a way that noise should be minimum. So without noise we can't get any signal, but this noise can be eradicated. So how this noise is very important here is, the noise is all present in the environment or in the spectrum, which is unavoidable, but it could be minimized. How this minimization is done is what we are going to study now. So if the channel is assumed to be this electromagnetic spectrum, then this noise is represented as spurious electromagnetic waves, which can be obtained or targeted in the radio receiver. So here there are several types of noises available. One about is thermal noise. This thermal noise is nothing but a major source of channel noise, which is that is segregated, which is a part of this channel noise, and it is caused due to the random motion of the electrons in the conductor and receiver, which is placed at the front end of the transmitter, front end of the receiver. So front end of the receiver in the sense, whatever the device we are going to build here to receive that signal. So we should understand all this transmitter section or receiver section is made up of electronic components. Those electronic components, when it is switched on, there will be a current flow. There will this flow of electrons, that is any charged particles, that may result in this thermal noise. That is the actual part you should understand. So here, if it is understood, that is it is concluded that the received signal is random in nature. So why is it so? Because we can't predict what is the type of signal or where the signal is obtained, right? So hence the signal is random in nature at the receiver end. As a result, it is not possible to predict the exact value of the signal in advance. So we can't say this is the signal we are going to pick up. Why means because this channel is an open channel where many kinds of signals will be transmitted. So likewise, many transmitter, many receiver will be placed in the environment. So all these signals are using only this medium, that is the channel. So that noise, that there the channel is inferred by this noise. So the receiver must be able to pick out which signal is to be received by that particular receiver. So this is unknown. Hence we can say, we can describe it, the channel which is a stochastical in nature, that is it is random in nature. So that is what I am going to conclude here. As a result, it is not possible to predict the exact value of the signal in advance, but it is possible to describe the signal in terms of statistical parameters. So we are going to find or average a model based on what will be that signal appearance, right? In terms of statistical parameters like average power and power spectral density. So here you need to know, always when we are going to study about noise parameters, this terminology is very, very important, which is termed as power spectral density. Hope you have understood what is noise and how it is very much important in any communication system. So we are going to continue the third unit with noise in further classes. Hope you understood. Thank you for watching.